So today, quality, particular lines, midpoints, and using Pythagoras theorem. Um, Wait, you can plug in a bunch of x values and get a bunch of corresponding y values, and you can put those x y values on an x y axis, right? And when you put those points down, the points form some kind of line, which we call the graph. So that's basically what graphing was all about. Now, quadratic graphs form from quadratic equation. What does a quadratic equation look like? In general, it looks like this, where a, b, and c are constant numbers. Okay, so for example, you have y equals 2x squared plus 4x minus 3, etc. This is a quadratic equation. Okay. Linear equation, on the other hand, as you might remember, looks like y equals mx plus c. That's the general form of a linear equation. And we know that linear graphs look like this, a straight line. But quadratic graphs have a different shape. Now, to show you that shape, I'm just going to take you through a little experiment, and I'm going to show you how we can actually prove that the shape looks a certain way. For example, let's pick a simple looking one. 1x squared plus 0x plus 0. So this is technically a quadratic, right? Because a is 1, b is 0, c is 0. And to be more specific, it's a quadratic because the largest power of x available in this graph is x squared, right? So that makes it a quadratic graph. Okay, so now let's try to plug in some random x values and get the corresponding y values out of that. For example, if we plug in 0 or minus 2, what do we get as y? What will y be if x is minus 2? Leona?
Oh, wait, what?
Uh, minus 2, what will y be?
Four.
4. If x is minus 1, y will be 1. If x is 0, y will be 0. If x is 1, y is 1. If x is 2, y is 4. The reason is that y is simply x squared. So whatever x is, y is going to be the square of that. Now if we put these points on the graph, it will look something like this. Minus 2, minus 4. Sorry, minus 2, 4. Minus 1, 1. 0, 0. 1, 1. And 2, 4. As you can see, it forms a parabola. So this shape is what we call a parabola. Very common shape. It results from quadratic equations. Okay. So this is the basic idea of, what the general graph of a quadratic looks like. Now, there are some important things you can find out about the shape of the graph just by looking at the equation. So what can you find out? So for example, if you take a general quadratic equation, if a, the coefficient of x squared, is positive, you will get a U-shaped parabola. But if a is negative, meaning the coefficient of x squared is negative, you will get an N-shaped parabola. Okay. Um, so this is one of the major keys to remembering this. Okay. So if the coefficient of x squared is positive, it opens up in the positive side. If the coefficient of x squared is negative, it's going to open up in the negative side. So this is one of the first rules, I guess, that you've learned, or general things that you've learned about parabolas. Okay. Now, we've already talked about how to draw a graph. Just make a table of x, y values, and for different x values, find the corresponding y values and put them on the graph. And that's basically it. Okay. Now,
Okay.
um, let's talk about solutions of some equations now. So, solving equations of the form, for example, ax squared plus bx plus c equals 0. So, see, this is an equation that can be solved, right? Because you have a bunch of x things equals a number. So you can solve this equation. Now, the question is, how do we solve this? Now, the thing is, we're already supposed to know how to solve this using quadratic factorization, which is something that I'm gonna send you the recording of, that I have sent you the recording of, but I don't know if you have been able to watch it yet. But solving this algebraically, like by hand, without graphs, is pretty straightforward. You factorize this, and then you solve it. But the cool thing is, you can actually solve it graphically also. Okay, how? Thing is, um, what you have to like, this is very important, by the way. When you have an equation, any equation in the world, there's always two ways to solve it. You can either solve it algebraically, or you can think about the whole equation as a graphical problem. How? Think about the left side of the equation as a graph, like that. So y equals the left side. And think about the right side as also a graph. So y equals the right side. Okay? Now, draw these two graphs on your xy axis. So ax squared plus bx plus c can look like any parabola. I don't know what it looks like because it's a general thing, right? Can look like any parabola. It can be anywhere. Could be literally anywhere. Or even it would be like this. I mean, it could be upside down even. I'm just drawing a random parabola. And then draw this line. Can you tell me what this line looks like?
Um, like straight line. Uh,
Of course, it's a
Um,
straight line, but especially what kind of straight line?
like don't know how to explain.
Try to, yeah, I mean, I don't know how to try to draw it, I guess.
Would it just go um like that?
There you go. Horizontal, exactly. It's a horizontal line at y equals 0, basically. What do I mean by at y equals 0? Because see, the y value over here is y equals 0, isn't it? So it's at exactly y equals 0. So once you've drawn the graph of the left-hand side of the equation, and you've drawn the graph of the right-hand side of the equation, simply find the intersection between the left-hand side and the right-hand side. Okay? So in this special case, we are looking for these 2 points. Okay? And that's it. Of course, we would need a very good graph of both of the graphs. I mean, we would need a very good drawing of both of the graphs to find out what these x values actually are. But you get the point, right?
Mm-hmm.
Okay. But remember, extremely, extremely important idea. Okay. How to solve an equation graphically. This thing, it's insanely, insanely important. Do not forget this. Draw the left-hand side and the right-hand side as two separate equations on a graph and find the interceptions between the left and the right-hand side. Okay? I'm going to show you another example of this situation because, um, one moment, because sometimes it's not as easy as finding this, right? So all the questions actually in the book are pretty straightforward. So I'm going to show you another example of this situation. For example, if you have 2x squared minus 4x plus 3, actually I'm going to use this, 2x squared minus 4x, 2x squared minus 4, sorry, equals minus 2x plus 3. Okay. Now this equation you can actually also solve using the same method. So which two equations do I need to plot on the graph now?
2x squared take 4.
Okay. The left-hand side
Uh,
and
negative 2x is 3.
exactly. Now, on the graph, it'll look something like this. So you don't know this yet because we haven't gone over transformations, but 2x squared minus 4 will look something like this.
Okay.
And y equals minus 2x plus 3 will look a lot like this. Now, as you can see, so what do you think are the solutions where are the solutions to this equation? Can you draw it on the graph?
Uh,
Which x
this,
values would be the solutions,
uh,
basically? Sorry?
this thing, and that thing.
Well, what about them? Because these are x, y values, right? So
Where,
which part?
where they both intersect.
Yeah,
Like,
exactly, but they're points. So points have x, y values, they're coordinates. But how can the solution be a coordinate? We ex this equation has a solution as x values, right? When you solve this equation by hand, you will get only x values out of it. So what I'm trying to say, you see what I mean, right? When you solve this equation
yeah,
by hand, yeah. So the answers are not the whole point, but just the x values of the points. Okay?
okay.
Yeah. Are you sure you get it? Because the thing is, when you solve an equation by hand that has x in it, you're only gonna find x. So naturally, we will only pull out the x values from the points that where the two graphs are meeting, basically. Okay?
Okay.
So we pick the x coordinates of both points, and we use that as a solution to our equation. Okay? So whatever these are, I don't know what they will be. We'll need a good sketch again to do that. And that is it. That's all you need to know about your graphs 4. So now we're talking about graphs 5. Okay. Now the first thing we gotta discuss here is whether you are good at sketching a linear graph. Okay, this is extremely important for this chapter. Okay. So for example, if I give you equation like y equals 2x plus 3, do you know how to sketch this graph? Just so when I say sketch, all that matters is you get the general shape of it, right? Okay. So like if it's, if it's a positive slope, you draw it like this, not like this, etc. And you know where to put the y-intercept. Okay. And that's it. That's all I care about for a sketch. So where do you think the y-intercept of this graph is going to be?
That's the
At 3. Because that is your y-intercept. And is the slope going to be upwards or downwards? Positive or negative?
positive.
Yeah, because this is positive. So we get a line something like this. Okay.
Okay.
Okay, that's my first question to you. My second question for you is, can you tell me what the x-intercept is in this graph? So y-intercept is 3. What about the x-intercept? How do you find the x-intercept of a graph?
Um, we found that, the X values, the graph.
No, not the x values, not plural. I need the one x value that is at the x-axis.
Yeah, yeah, yeah.
We've already gone over this a lot of times actually. So to find the x-intercept, you will have to think about the point at the x-intercept, right? Think about this. Ask yourself, what do you know about this point? Do you know anything about this point?
That's over.
Sorry?
X, uh,
You said something just now. What was it?
at 0.
What is 0?
Well,
Is x 0 or y 0 at this point?
both of them.
No, how could
No,
x be 0?
X.
X is 0 here. X is 0 over here, right? And y is 0 over here. This point is the only point where both of them are 0. You need to remember
Um,
this, okay? This is like you keep forgetting this is extremely important because you're gonna have to do this almost in every question. Look, this is the y-axis, right? So over here, y is 0 all across. Over here, y is 1 all across. This over here, y is 3 all across. Y is 4 all across on. And this is the x-axis. Over here, all x's are all 0. Over here, x's are all 1. Over here, x's are all 2, 3, 4. Okay? So if you go anywhere to the left of the middle of the x-axis, you will not be at x equals 0 anymore. And if you ever go above the middle of the y-axis, you will not be at y equals 0 anymore. If you're at the middle of the y-axis, y is 0. If you're at the middle of the x-axis, if you're at the middle of this line, x is 0. Everywhere over here, x is 0 because you're at the middle of the x-axis. Okay? So again, at the x-axis, what is 0? Think, what will be 0 here? It's y. Y is 0 because you're at the middle of the y-axis. You need to like make a note of this and always remember this because it's very easy to remember and it's extremely important that you don't mess this up because this will be the beginning of a question basically, trying to find out the x-intercept.
uh,
On the x-axis, y is 0. On the y-axis, x is 0. That's basically it. So on this point, y is 0. Now, if y is 0, then how do I find out what this point is?
you put in the equation.
Exactly. You put 0 into the equation and you try to solve for x. So how do I solve for x now?
Um, -3 both sides.
Okay.
X will be equal to -3 over 2.
X will be what?
-3 over 2.
X will be equal to -3/2, yes. So this is your x-intercept. So remember, this is how you find your x-intercept. This is, again, extremely, extremely important that you do not forget this. It's very important. So these are the few things that you're going to need to do when you're asked to sketch a graph. You need to get the slope right, you need to get the y-intercept right, you need to get the x-intercept right, and that's it. Okay? With that said,
Okay.
that's the recap, by the way. All of this was from like a few chapters ago. Now we need to talk about linear inequalities. So representing linear inequalities graphically. So thankfully, the idea stays pretty similar. So for example, let's say that you're asked to sketch x plus y is less than 4. My favorite way to do this is to first make y the subject, okay? So I subtract x on both sides and I get this nicer looking equation. Now, just forget about the inequality for a second. Just think about what the line would look like if it was an equation, okay? Can you make me a sketch of what the line looks like? Absolutely not. It's impossible.
Look, wait. Alright. What's the thing?
Exactly. It looks like that because you have a y-intercept of 4, meaning you have to hit the y-axis at a positive number, and you have a slope of negative, which means you have to go downwards. Okay, perfect. Can you also tell me maybe what the x-intercept is going to be? So what's the x-intercept going to be?
-4.
Sorry?
-4.
Does that look like a negative number to you? Wouldn't it be weird
Oh
for a
wait, no.
negative number to be here? Come on, be careful.
4.
4, exactly. It's very clearly just going to be 4. You plug in 0 for y, you subtract 4 on both sides, you cancel out the negative, x is 4. See? You got it? Is everything making sense, by the way, so far?
Yes.
Okay, perfect. Now, here's a little trick, by the way, to be faster. If you ever see an equation of this form, just x plus y and just a number, okay? Not 2x plus y, not 5x minus 3y, just x plus y is equal to a number, okay? Your line will always look like this. The y-axis and the x-axis will hit at the same number, which will be this one, okay? So if this was x plus y equals is more than 9, for example, I would just make the line that hits at 9 here, and that's it, okay? So it's a bit of a trick, but I never suggest to, kind of memorize that because it's always better to do it the long way because it's more concrete that way. Okay. Now, the thing is, we've drawn the line. However, by the way, it's less than or equal to. So who's getting a call? Okay, anyways. So the thing is, we've only drawn this line, but this line represents x plus y equals 4. Okay. But we have an inequality, or this line actually represents y is equal to minus x plus 4 similarly. But we have this inequality to draw. Okay. So what does that mean? We need to shade a specific region that satisfies this inequality, basically. Okay. So how do we figure that out? It's quite simple. You see, this is the line where y is exactly equal to minus x plus 4, but we need where y is less than or equal to minus x plus 4. So we want to be under the line because y is less than. So y is less than minus x plus 4. Well, less than or equal to, actually, but regardless. So when you say less than or equal to, you're talking about under the line. Okay? Okay? So the
Okay.
shaded region in this case would basically be all of this area. So what does that even mean now, though? Right? What does that mean? That means that if I pick any point in this region, it will fulfill the inequality I have. So let me show you an example of what I mean. So can we pick a point that is very clearly in the region that I've just shaded? Like for example, this one. Okay. What is this point? Let's call it minus 10, 0. Okay. So you see how it's in the region, right? It's very obviously inside of this region. So let's see if it fulfills my inequality. So let's take my inequality and plug in the x and the y value. So what do I plug in for y? If I want to
Yeah.
check this point, 0. And what should I plug in for x?
-10.
Exactly. So there's already a negative there, so minus negative 10 plus 4. And as you can see, 10 plus 4 is 14. 14 is indeed more than or equal to 0, so it is satisfied, which means that what I'm trying to claim is that every single point in this entire region will fulfill the inequality, will satisfy the inequality similarly. Okay? It will not break the inequality. Now, let me show you what I mean by breaking the inequality. If I pick a point that's not in this region, for example, this one, like 10, 0, basically, okay? And I plug in this into the equation. So 0 is less than or equal to minus 10 plus 4. As you can see, I get 0 is less than or equal to minus 6, which is not true, right? I just broke the inequality. So what I'm saying is that if you pick any point outside of the region, your inequality won't work. It'll give you a false answer. See? So that's how inequalities work, and that's what this shaded region means. Okay? Everything clear?
Yeah.
Okay. Now, there are two nuances that you need to remember. What happens if you have x? So I'm going to draw two examples. X plus 4, or yeah, x plus 4 is less than 3, and let's say y is more than or equal to 2x, for example. Now, first of all, If I want to draw both of these on the same graph, I can. X plus y is less than 3. Remember the little trick I told you? You can just directly draw this by just putting 3 here, and connecting them. Okay? Only works in specific scenarios where you have x plus y, okay? What about this line? Okay, so that's what I was going to say. Now, since it says less than 3 and not less than or equal to, you have to draw a dotted line because you're trying to say that this line, you cannot use any point on this line either because you need to be strictly below this line. You cannot be on the line either. Last time, we could have been on the line also. We could have picked any point on this line and it would still satisfy our inequality. But this time, since we're not allowed to pick the points on the line because it says less than and not less than or equal to, we make a dotted line. And similarly, in this case, we have y equals more than or equal to 2x. The y equals 2x would look like this, the line itself. And we can draw a full line because it's more than or equal to, not more than this time. Okay, so now let's sketch the regions that we need to sketch. Okay, this is less than, so we need to draw, oops, one sec. So as you can see, it says less than 3. So we will shade the region that we want, which is under this line. And now, for the more than or equal to 2x, we will shade the region that we want, which is above this line. And then look at the overlap. What is the overlap? This part, just this part, right? So this is my final answer. I can pick any point in this region, and this will satisfy both of my inequalities at the same time. That's the answer. Okay. So if I pick any point over here in this region, like this point, or this point, or this point, etc., it will satisfy both of my inequalities at the same time. Okay. That's the idea. Is this clear?
Yeah,
Are you having any trouble understanding anything so far? Everything makes sense completely?
yeah, makes sense.
Okay, good. So now, and just to remind you again, if I say x is more than 4, what kind of line is that going to look like? What kind of line will this be? Can you maybe sketch it even if you want?
Uh, it would be a line.
Yeah, it would be a vertical line at x equals 4, exactly. But would it be solid or would it be dotted?
Dotted
Because, why?
is doesn't have the equal to.
Exactly. It just says it's more than, so I can't be on the line. So I specify that by dotting the line. Okay, and it's at x equals 4. And now which region do I need to shade? If I want to shade the wanted region, the region that is satisfied, which region should I shade?
Right.
The right of this line, because I want to be more than x equals 4, right? So everywhere to the right of this line will work, but not on the line, by the way. Careful. Okay. So now, next up, we have to talk about perpendicular lines. Have you learned about perpendicular lines before, by the way?
Yeah.
Okay. So do you know what the idea of parallel lines is first? So just to remind you, for straight lines, so we're not talking about inequalities anymore, we're just talking about regular like equations now, okay? So y equals mx plus c. That's a straight line equation. This is the slope of the line, and this is the y-intercept of the line. Okay. Now, you already know that if two lines are parallel, what happens? Like for example, parallel lines. What's the whole like, deal with them? How do we see that they're parallel by just looking at their equation?
Like they will never intersect.
No, no. If you just know the equations, how can you tell that they're parallel?
But they have the same slope.
Okay, and how will that appear in the equations?
Huh?
How how do you check if two lines are parallel? By looking at their equation. How will you know that their slopes are the same?
They have the same um and
M, exactly. The coefficient of x will be the same in both equations. So for example, are these two lines parallel?
yeah,
How? Their M values aren't the same, are they?
with like legal range. Right?
Sorry?
You don't rearrange it just to have line its
Yes,
own.
you have to rearrange them, exactly. So y equals, what is the first equation going to become when you rearrange it?
Uh 2x, take a 3/2.
Exactly. And the second equation is already 2x plus 6. The y-intercept doesn't matter. The m values being the same means that they are the same slope, meaning that they're parallel to each other. If I want to sketch both of these lines, can you actually put them on the graph? Do a rough sketch, by the way, don't worry.
You know,
Exactly, yeah. Because one of them will have a y-intercept of 6, the other will have a y-intercept of minus 3 over 2, but they're both going up at the same exact slope. Does that make sense? By the way, your voice is cutting out, I think.
oh yeah, it does. It does.
Okay. So that's parallel lines. Okay, this is a recap. Now let's talk about perpendicular lines. What are perpendicular lines? Perpendicular lines are lines that are 90 degrees to each other. Okay, so lines that are exactly 90 degrees to each other. Oh, that's the xy axis. If you draw two lines that go like this, perfectly 90 degrees, we call those perpendicular lines. Okay, now the question is, obviously with parallel lines it's easy to tell. Just look at their slopes, check if they're equal. But with perpendicular lines, how do you check by looking at their slopes that they're perpendicular? It's very easy. The rule is that if the slopes of both the lines have a product of -1, if you multiply the slopes and they give you -1, that means that they are perpendicular. That's the requirement. For example, this, this. Both of these lines will be perpendicular. How? Because look, the slope of this guy is 2, and the slope of this guy is -1 over 2, right?
Is it the same as like next reciprocal?
Yeah, exactly. Because as you can see, if you just divide both sides by m2, you will get this negative reciprocal. See,
Okay.
if I just divide both sides by m2, the m2 is going to be downstairs, which means m1 is -1 over m2, which means negative reciprocal. Reciprocal means just to flip the number. As you can see, 2 and -1 over 2 are indeed negative reciprocals of each other. But if you want to show it more clearly, just show that when you multiply 2 and -1 over 2, you get -1, which proves that they are perpendicular lines. Okay? Similarly,
Uh,
if I tell you, sorry, any question?
no.
Okay. So if I tell you that this is one line and then there's another line that is perpendicular to that line, and I want you to find the slope, you can use the same idea. You will say that if they're perpendicular, the product of their slopes must be -1, which means that the slope must be -1 over -3, which is indeed 3. Oh, whoa, which is 1 over 3. So you found the slope again. Of course, a lot of people skip this step where they're just like, okay, let's just do negative reciprocal, and they do -1 over -3 and get the answer directly. But remember that the main rule comes from this equation, okay? The rest of these questions are going to be very similar to everything you've already done, okay? So you know the whole deal where they give you a point and then they tell you that this line is perpendicular to that line and so on and so forth. So I'm going to leave most of these questions for you as homework because there is one last idea we need to discuss before we finish, which is midpoint, which is something actually I feel like I've already gone over with you also. Am I right?
Mhm.
So midpoints are basically just as they sound, they're the point that comes directly in the middle of two points. Okay. Very easy to understand how to calculate them. Very easy to remember too. Let me show you. So like imagine 2 points, random. Like this one, let's call it x1, y1, and this one, let's call it x2, y2. Okay. And I want to find the distance between these two guys. Now, the thing is we use Pythagoras to do this. We make a right angle triangle because we know what this length is. This length, how do you find it? You simply find the difference between the two numbers, x2, so like the x value of this guy and the x value of this guy. Let me actually draw this a bit better. So if you know the x value of this guy is x1 and this guy is x2, you can find the distance between them by just subtracting x2 from x1, right? Is that clear?
Yeah,
Okay. And if you know the y value of this guy is y1 and this guy is y2, similarly, you can find the y distance between them by just doing y2 minus y1. So now, what do you have? You have a triangle where you know the x distance and the y distance, and you're trying to find the hypotenuse, right? So what should we do? We should just use Pythagoras. Sorry. Oh, midpoint. I'm telling you about the distance, I just realized. Well, let's just finish this, I guess. So I'm not talking about midpoint. I forgot that we're talking about midpoints and not distance formula. But the distance
it's
will
fun.
simply be x2 minus x1 whole squared plus y2 minus y1 whole squared square root. Just using Pythagoras, right? So to find the distance between 2 points, you will simply do difference in their x value squared plus difference in their y value squared and then square root over all of it. Is that clear?
Yeah,
Good. So now, with that said, let's talk about what we were actually supposed to talk about, midpoints. So midpoints are actually pretty easy. So think about it like this. Um, let's say that you have this point, or let's say this point and this point. And let's only think about it in the x perspective for a second, right? The point in the middle, right there, its x value will be exactly the half of, exactly in the middle of x1 and x2, right? Because it's the midpoint. So the x value will be in the middle of the x values of the boundary points. You see what I mean?
it's fun.
So to find the x value of the midpoint, simply find the average of the x values of like the boundary points. So how do you find the average of x1 and x2?
You add them to one by two.
Exactly. You just add them up and then divide that by 2. That's the x. And of course, naturally, without even writing anything, what do you think the y value will be for the midpoint using the same idea?
For y.
Yeah. Sorry?
Y one plus y two with two.
Exactly. Just add the y values, divide that by 2. So this way you can find out the x coordinate and the y coordinate of the midpoint. Okay? And y coordinate. And that's it. That's how you find the midpoint. Okay? So let's do a quick question now, a very common one. Okay. So the question is about finding the perpendicular bisector of 2 points. Okay? So how do you find perpendicular bisectors of 2 points? Pretty straightforward again. It's a very common question. It shows up almost every time in an exam. The first step is realizing what they're even saying. They're saying They're asking you to find the equation of the line that is a perpendicular bisector of AB. Okay? Perpendicular means that it is 90 degrees. Bisector means that it passes through the center. Okay? This is the key. Passes through the center. And this one means that the slope of the new line will be basically minus 1 over the slope of AB. Do you agree? Because, if it's perpendicular, then it will be the slope of this line, the slope of this line, the perpendicular bisector line, will be negative reciprocal of the slope of AB. Because see, if AB is like this, the line that we're talking about is like this. This is our line. And for example, if this is A and this is B. So these are the two things that we've understood. We need to find the midpoint and we need to find the slope of the line. Let's start with the slope. So first we need to find the slope of AB itself. For the slope of AB, just do y1 minus y2 over x1 minus x2, whatever. So you can do 1 minus negative 1 divided by 4 minus negative 2. 1 minus negative 1, 4 minus negative 2, which is 2 over 6, which is 1 over 3. This is the slope of AB itself. But of course, we want the perpendicular bisector of line AB. So since the line that we're talking about, let's call it L, is perpendicular to AB, the slope of the line L will be what?
Negative 3.
Exactly. Just the negative reciprocal of 1 over 3, which will be negative 3 over 1 or just negative 3. Same thing. Okay, we found the slope. Now, the thing is we cannot find the equation of a line if we only know the slope. We need a point on the line also. How do we find the point on the line? Well, it says that it's a bisector of AB, which means that it cuts AB exactly in half. So we need to find the midpoint of AB, okay? Because we know that our line passes through the midpoint of AB. So what's the x value going to be for the midpoint of AB? Leona?
1.
How did you find that?
4 plus negative 2 over 2.
Exactly. And what about the y value?
0.
Exactly. 1 plus negative 1 over 2, which is indeed 1, 0. So now that we know a point on the line also, we can we know the slope and a point, and we can now go ahead and find the equation of our line. So which method do you use to find the equation of the line? Do you use the y minus y interception thing?
No.
So how would you find the equation of this line?
By using a point.
Okay,
By using
elaborate.
you know how like would be the general formula is y equals mx plus c.
Yeah.
Substituting this point into
So how do I
x and
substitute this
y.
point? So what does it become?
1 is equal to negative 3.
No, 0 equals
Oh, so
y is
yeah, this
0.
is
0 equals,
negative 3
that's the slope,
bracket 1
plus,
plus c.
okay. And so c is
3.
3. Because you have minus 3 plus c, you add 3 both sides, so c equals 3. And you already know m, and you now know c, so you can now finally state that the perpendicular bisector will have this equation in general. That's your answer. This question is going to show up in almost every single exam for sure. So learning how to do this will be extremely, extremely important. It's going to be required basically for the exam. Okay.
How many marks is this?
I would say that this specific
3.
question would be like 4 points at max. Four at
Nice.
like 4 max. But of course, they can make it a bit more difficult depending on what the other questions in the exam are like. But yeah, generally this is 4 to 5 points maximum. Okay.
Correct.
Okay, so now I'm gonna put some questions on the board for this chapter and the last one, and I think we can end the recording now.